In the last class, we have seen introduction of machine learning. What is the meaning of well-posed learning system? In today's class, we'll see how to design a learning system. That is, before we use machine to do some task, we should make machine to learn. So for that, first we need to design a learning system. Designing a learning system involves various stages. The first step is choosing the training experience. Next step is choosing the target function. Third step is choosing a representation for target function. Fourth step is choosing a function approximation algorithm. Last is final design. So we'll see each of 5 steps in detail. The basic design issue here is illustrated by considering designing a program to learn play checkers with the goal of entering it in the World Checkers Tournament. So we adopt here the performance measure, that is the percent of games it wins in this World Tournament. So before taking this example, so we'll go with the brief discussion about what is checkers learning program or checkers learning problem, means what is the motivation behind this example. First machine learning system was developed in year 1950s. Later in 1952, Samuel, who was at IBM, he has developed a program for playing checkers. So which I explained in last class. The program was able to observe positions at the game and learn a model that gives better moves for machine player. The system played many games with the program and observed that the program was able to play better in the course of time with getting more experience of board games. So Samuel coined the term machine learning, and he defined learning as a field of study that gives computers the ability of without being explicitly programmed. So by considering checkers learning problem as an example, we train the machine how to play checkers game. Once it learns how to play game, we can use that machine to play in the World Checkers Tournament. Okay, let us move on with the first design choice, that is choosing the training experience. The type of training experience available can have significant impact on success or failure of the learner. That means if you want to drive a car, so only just watching videos of driving car, after watching videos, if you want to take a car, means if you want to drive the car on road, so that may lead to end with an accident. So what kind of training experience we need here is to drive a car. So we need to get training from well experienced person, or we need to go to driving class to get better experience. So always training experience can have significant impact on success or failure of the learner. We can say there are 3 attributes which impact on success or failure of learners. The first attribute is whether the training experience provides direct or indirect feedback regarding the choice made by the performance of the system. So if you are taking the example of driving car, so here what is the direct feedback? Direct feedback means trainer sits beside you and he is giving suggestions when driving a car. So what is meant by indirect feedback? In the absence of trainer, suppose he is provided recorded video of driving car, so that is called as indirect training. Means that video may not be related to your driving situation. In the same way, in checkers game, when you are playing the game, there are only if you are playing the game, then you should come to know, uh, you should select what kind of move. What is the indirect feedback here? That is, in the indirect feedback means it's already stored what kind of moves you should play to win the game. So you just follow the instructions. So at the end you may win or lose. So for example, in mobile games we can see game with many hint buttons. So mobile stored with the possible moves to win the game. So what is the drawback here? If you win, so you will give credit to that hint which made you to win. But if you lose the game, so you may blame. So that is called credit assignment problem. So that is, if hints are already stored based on winning a final outcome, so credit assignment problem usually occurs in indirect feedback. So that is, credit assignment can be particularly difficult problem because the game can be lost even when early moves are optimal, if these are followed later by poor moves. Hence, learning with direct training feedback is typically easier than learning from indirect feedback. Second attribute is degree to which the learner controls the sequence of training examples. So for example, if you are taking same example, that is driving car, there are three cases we can consider. The first case is when trainer is sitting beside you and he is giving every instruction to drive a car. Second case, trainer just sits beside you. If you are doing only mistakes, that time he will give suggestions. So the third case is means trainer is not giving any instructions. If you are doing any mistakes, you only need to correct it. So we can categorize the degree to which learner controls the sequence of training examples as no freedom. That is, supervisor provides all training examples. Semi-free. That is, supervisor provides training examples. System constructs its own examples too and asks questions to the supervisor in cases of doubt. Another choice is total freedom. That is, system learns to play completely unsupervised. Third attribute is how well it represents the distribution of examples over which the final system performance P must be measured. That is, how representative is the experience. So if you are taking the example of driving car, suppose the trainer provides training only to drive car on the school ground. Then it will effect for driving car on road. So instead of that, if suppose the trainer provides a training experience to drive car on heavy traffic as well as in hilly areas, so you will get better experience. So that is, we should select training experience such a way that it should give better training experience. In our checkers learning problem, if training experience consists only of games played against itself, then there is an obvious danger that this training experience might not be fully representative of distribution of situations over which it will later be tested. For example, learner might never encounter certain crucial board states that are very likely to be played by human checkers champion. But to proceed with our design, let us decide that our system will train by playing games against itself. So this has some advantage that there is no need of external trainer and therefore it allows the system to generate as much training data as time permits. So final type of training experience we can select game against itself instead of game against experts. Playing game against itself, is that training experience is good? So we can say that the performance is best when training examples and test examples are from the same or similar distribution. But in our checkers, player learns by playing against oneself. So its experience is indirect. So it may not be encounter moves that are common in human expert play, but still it has one of the advantage that there is means no need of external trainer, and system can generate many training data as time permits.